Alrighty, guys, we are going to do our last topic here. Again, I know there's not another line. It's kind of a lie. We got to talk about graphing. So graphing absolute values. And we're actually going to do that on 80, 81, and 82. So 80 to 82. And if you want to be cute and stuff and put AB3, absolute value 3, topic number 3. That's what we're doing. All right, let's turn to page 80. And guys, on page 80, we don't have anything. We're going to do a separate video where I do some examples on those. I want to start over here where we talk about how to graph an absolute value function. Okay, so there's some stuff we're going to write over here. I actually want to start down here because the thing is, whenever I'm going to graph something brand new, I always start with a table. We even did that with lines. Like before we started talking about how to graph in y equals mx plus b, we made a table of values and we picked some x values and plugged them in to get the y values. We did this a long time ago. I want to say it was maybe even first marking period. Okay, so whenever I'm going to figure out what a brand new graph looks like, that's what I'm going to do. I always pick my x values and I like to pick some that are negative, 0, and some that are positive. So usually my go-tos are like -2, -1, 0, 1, and 2. Okay, you can pick your x's however you want. And then I just plug them into my function and figure out how much it is. So like the absolute value of -2 is 2. And then I have an ordered pair that I can go plot. So I go to -2, comma 2, and we plot that guy. Then I do it with the -1. So absolute value of -1 is 1. So I go -1, 1. Absolute value of 0 is 0. So 0, 0. Absolute value of 1 is 1. Ooh. Look at that. And then absolute value of 2 is 2. So we're at 2, 2. So this is kind of wild. It's doing like a V-shapey thing because I'm pretty sure it would continue on in this direction. Like 3 would be 3 and 4 would be 4 and 5 would be 5 and so on forever. And like all these negative numbers are always going to spit out positive numbers. So this is also going to continue to go up in this direction forever, forever. So we get this really cute little V shape. And any equation that has an absolute value in it will always create a V-shaped graph. Okay, so that's why we call this the parent function. The parent function is the most basic form of a brand new function. So like the parent function of a line, do I have my graph paper right here? I do. The parent function of a line would just be y equals x. And we talked about that one. It was like direct variation. It starts at 0, 0, and has a slope of 1, and it like just goes diagonally right through your quadrants like this. If I start making the slope different, it gets steeper or shallower. If I add a y-intercept or subtract one, it moves the line up or down. And so the same thing is true for an absolute value graph, except it will always have the shape of a V. Okay, so because it has the shape of a V, this point where these two lines meet is a really important point to find because once I know where that is, I can kind of do the V shape up from it in either direction, which in this case is going up 1 over 1 every time. So this point right here, this point where the two graphs come together, because it's so important, we gave it a real important name. It is called the vertex. And so this vertex is at 0, 0, but it's like where the lead duck is. It's like a flying V, and it's your lead duck. I always like to call it the lead duck, but it's like the point of the V, like where the V comes together. Okay, now that being said, not every absolute value function is just going to be this. And so that's what we got going on up here. Now, if you did our Desmos with us today in class, or the other day in class, we should have a good understanding of what A, H, and K should do. Now, just like when we were talking about y equals mx plus b, m got replaced with a number that we call slope, and b got replaced with a number that we got the y-intercept. And like the y-intercept is where we started, and then we would do our slope. A v-graph has a similar thing. We want to start at that vertex, which in this case is at h comma k. So h comma k is the vertex of the graph. It's where I should start, or your starting point. So guys, notice that h is inside being added or subtracted. So it's like inside the bars. K is outside the bars, also being added or subtracted. So your vertex always comes from an addition or subtraction thing. And since there's nothing being added inside here and nothing being added outside there, that's how I know that my vertex is 0, 0, because nothing inside, nothing outside, nothing as a number is 0. So if we start getting numbers in there, if my function now looks like 2 absolute value, x minus 3 plus 5, my vertex, so the x value of the vertex is going to be inside with x, but because of that subtraction sign, it's actually just 3. And then the y value of my vertex is going to be outside, either added or subtracted, and in this case is 5. It stays the same. So that's kind of another little weird thing. The inside number is opposite, the outside number stays the same. Now the other number that we need to talk about is the number that is smashed on the front, so the number that's being multiplied. So if we're thinking about y equals mx plus b to try to make it make sense, like something I already know, b was my starting point, my y-intercept, v is my vertex, h comma k is my starting point, that's where I go first. M was then my slope, and A is kind of like your slope. So A is slope in both directions to make that V shape. So like truly, you know, one of them is negative and one of them is positive. So we'll put a plus or a minus in front. Like here it's 1, but down here it's -1. So whatever A is, you'll do one in a positive direction, one in a negative direction to get both sides of your V. Another thing to note, if A is negative to start, then the V flips. So it'll be a downward V, right? Negative means I flip over. Okay. Just like slope, if A is a big number, so like bigger than 1, then your graph is going to go fast, fast, fast. Like it's going to be a really fast slope because it's a big number. So it will be a narrow V. Like it'll be really tight, really close together. Looks real skinny, which feels weird. Like skinny to me feels small, but it's going fast. So that's why it's skinny. And then if A is not bigger than 1, but not really negative either, really if it has a fractional slope, so it's like between 0 and 1, so like a half or a third or 3/4 or 2/5, anything smaller than 1 but bigger than 0, it really doesn't have to do with the negative. It's a fractional slope, then we're going slower, and so we get a wide graph or a wider V. Okay. Alrighty, so on the inside here, let's try a few now. If we take a look at this one, I don't really want to make a table anymore. I mean, we could, but if I just know what my graph should look like, always V, I'm going to find that starting point. I'm going to do my slope. I'm going to call it a day. So I can tell that my vertex here, since there's nothing being added or subtracted inside, it's going to be 0, comma. There's a 1 being added outside, so 1. So I'll go to 0, comma 1. And then I take my A value, which is 1, and I do a slope of 1 in both directions to make a V. So from here, I'd go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Going back to my vertex, I now need to do the opposite direction, again, to make a V. So I really need to do -1 slope now. So up 1, back 1, up 1, back 1, up 1, back 1. So guys, this one compared to the parent, so if we talk about transforming it, compared to the parent, this all just got shifted up 1. So shift up 1. I should have put my A in a different spot. Sorry about that. All right, moving right next to it. So I'm going to skip the tables because no thank you. If I look at this next one, I always find my vertex first. I look inside, and there is a number. So that's going to be my X value, but opposite. So 2. Then I look outside, and there is no number being added or subtracted anywhere. So that means it's 0. The other number that I like to identify is A, and A is the number being multiplied, and it's -1. Okay, so I plot my vertex at 2, 0, and now I do my slope of -1. So I go down 1 over 1. So this is a downward pointing V graph, and we got to do the same slopey over here, just in the opposite direction. And so we get this V. So when I talk about how it's different from the parent function, kind of 2 things happened. It went to the right 2, and it flipped. Because it's now pointing down. Alrighty, trying the next ones. Looking at this one here, finding my vertex first, I'm looking for numbers being added or subtracted. There are none inside, so 0. But there's a -1 outside, so -1. The other number that I like to identify is my A value, which is the number being multiplied outside, so 2. So I plot my vertex. I go to 0, -1. Then I do my slope on either side to make a V. So from here, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Then I got to flip it over, put it on the other side. So up 2 over 1, up 2 over 1, up 2 over 1. So a couple things happened with that guy. It got pushed down 1, so down 1. But it is also narrower, or like skinnier, than your original. So narrower or skinnier, either way. Okay. And then the last one, I'm going to find my vertex first by looking inside, outside for what is being added or subtracted. So inside is a +2, but inside is always opposite, so -2. Outside there's a +1, so 1. And then my A value is always a number being multiplied. And if I don't see 1, then it's 1. So I plot my vertex at -2, 1. And then I do my slope of up 1 over 1 on both sides to get that little V graph going. What a cutie. So when I compare that to the OG, the parent function, which normally starts at 0, 0, this guy went left 2 and up 1, but it is traveling at the same speed every time because a parent function travels at a slope of 1, so it's not any narrower or wider or anything like that. And in another video, guys, just to make this one not too long, I will do another few examples with you on page 80, and then we will do 82 in a separate video as well.